That's, you're not allowed to do that. So there. Okay. So what's wrong with Voltaire's critique of Leibniz's optimism, the best of all possible worlds? Well, he clearly doesn't understand what Leibniz is talking about. Or if he does, he knows that most people are not understanding it, and so he's going to take advantage of what most people think to make a hit play. Although he was in trouble, Voltaire himself, who's that's not actually his real name. Let's just go to Voltaire. There's another wig, or maybe not. His real name is Francois Marie Arouet, however the French would say that. You know how they usually don't say words all the way. That's the French way. But so in any case, he got in trouble for some of the things he said, and I think he ended up in Switzerland. Switzerland was a good place to go and hide out. That's where John Calvin went and founded his own church in Geneva, Switzerland, and so on. So all kinds of interesting things. Voltaire, by the way, I don't know if I mentioned it when I said I don't like Rousseau. I think he's an asshole. One of the things, I don't know if I mentioned it, was that he wrote to Voltaire and says, "How do I become famous?" Did I mention that? Yes? Okay. And Voltaire says, write things that are just the opposite of what everybody believes. And Rousseau does that and becomes famous. So that's kind of cool. But what is the best of all possible worlds from Leibniz's point of view? If you look at Brian Greene, the idea of the multiverse, hypothesis. Which, this is
What
physics.
is the multiverse? Can modern physics reveal the deep mysteries of the nature of reality? Or realities? If there are multiple universes, does it really mean there are infinite worlds where you already know the answer to this question?
The word universe meant everything, the totality, every star, every galaxy, the whole shebang. So what sense could there possibly be in having more than one everything? And what we have found in research that actually dates back a number of decades, but most vigorously relatively recently, is that our mathematical investigations are suggesting that what we have thought to be everything may actually be a tiny part of a much grander cosmos. And that grander cosmos can contain other realms that seem to rightly be called universe, just as our realm has been called universe, which means that you have many universes, multiple universes, which we call the multiverse.
Discover an unexpected surprise inside every Kinder Joy.
Physicist Sean Carroll can...
So I'm not going to keep following that, but basically the argument that Brian Greene points out is that of all the logical possibilities, the mathematical possibilities to explain all the different universes that are out there, our universe has a very peculiar amount of dark matter versus everything else, and the amount of energy that's in our universe, which enables stars to form, planets to form, atmospheres to form. Did I already say this? Etc. So that basically we can have life. And that on all the other universes, which are different mathematically by just a little bit, none of this stuff can actually form, despite the impression you might have gotten from the graphics there where all the universes look alike. Actually, the theory explains that there's all these possible universes out there, and none of them would have ended up with the kinds of things we have, because our universe is unique in the way everything all works out, right? And so basically, that's the contemporary model explanation of what I believe Leibniz was actually trying to say, so that of all the possible worlds that could have been created, or universes, right, this is the best possible one, right? Now, his main argument was, by definition, God being that in which nothing greater can be thought, and is, all powerful, all good, etc., God would not have created a miserable universe. He would have created only the best possible universe, because God is that way. Well, that doesn't mean what Voltaire takes it to mean, and that is that everybody gets 2 chickens in a pot. That's actually Franklin Delano Roosevelt. Sorry, the 1933. He wanted a country where everybody gets 2 chickens in every pot. That's a Franklin Delano Roosevelt thing. But no, we're not in that kind of universe where nobody dies, or nobody is rich, versus poor, and all these other things that we can think of that, of course, as Augustine says, we view it as evil. And so from our point of view, this is evil. I really should have gotten an A for the course. Instead, he gave me a B. Yeah, that's your perspective on it, etc. But the idea, of course, is apart from all of the, diversity and, am I allowed to say that in the class? But all the possible kinds of things that could happen in the world. Some we would think of as good, some we would think of as bad, and so on. But what Leibniz is basically saying is, this is the best universe that can be, including all of these things. You get the idea?
I sure don't think of how bad other universes must be then.
Well, you wouldn't even have stars, you wouldn't have planets, you wouldn't have atmospheres, you wouldn't have life.
So
by comparison, this is, where would you be?
In theory, everything is slightly different. It's just doesn't exist at all. Like in another universe, you don't have a being.
There isn't.
Vastly different.
Yeah, that's kind of misleading. A lot of people talk about, every time there's a decision point, you end up with a different universe, because the one universe says take the left road, the other one says take the right road. There's a split in the universe. You hear that from some people. That's not what Brian Greene is talking about. Brian Greene is saying in physics, the numbers that we have that enable this universe to work with all of the possibilities that we have, as huge as it is, and where they really think there's a lot of life out there on all these different planets, on different stars, and where you got that much out there, this can't be that unique, right? But nonetheless, the universe as they map it out is unique. So in that sense, that seems to me what Leibniz is saying. It doesn't mean it's going to be the best world for everybody. And so Voltaire is basically just taking, making the best or the worst argument, in order to set up Leibniz as a foolish individual. So the best of all possible worlds theory, that's how I would interpret it. But is that a theological writing that Russell's critiquing? I think so, because of course what Leibniz is basically saying is based on the theology that we have to accept that God is such a thing and created the universe. This has to be the best of all possible worlds. So he's not framing it the way Brian Greene is, right? That's not what Leibniz is doing. He's taking a theological point of view and saying that. But I do think his interpretation of this is the best of all possible worlds means you couldn't have had a better one. That's just the theological argument, right? Anything else would have been worse somehow, right? But so there are inconsistencies. He is, I I think I mentioned already last class that Sir Isaac Newton gives us a steady state universe. So if we look at Sir Newton and we get a steady state theory, what's that look like? Basically, the universe is kind of constant, right? I guess is the word, constant density, constant, all sorts of things, so that, everything basically is repeating within a model that's stable. But at the same time, Leibniz is arguing a theory of relativity instead, and that is that everything, such as our position in space, is relative to a particular subjective standpoint, right? So you have to have who's the perceiver. Depending on the perceiver, that's the center, right, of the universe for you. So when we look at the model that we get from Einstein, right, the time, space, cone, I guess is the best. Right, when you get these, the light cone, there's the example, right? Remember, when you get these, the very center there is you. So that's, so everybody's universe is slightly askew of everyone else's. Clearly ours are very close, because where you are and where I am, the speed of light, that's hitting you is very close to what is hitting me, etc. So as a result, we're very close at the moment. But notice we do move apart. And so it's interesting that there's images of this that give you all these. I love this one, right? So that gives you the idea that everybody's got their own little version of the universe, and we're all interacting with one another. That's more like Leibniz than, because everybody's perspective then is from their point of view, right? So there's a difference that's relative in that sense, and that's not what Sir Isaac Newton was saying. He was describing things as, everybody's in the same universe. I'm here, you are over here, you're over, right? That's the difference of that model. And Leibniz, the difference between necessity and contingency is based on the need for a transcendental ground for all existing things. If God exists and created everything and knows everything, then everything is necessarily the way it is, because that's how God made it. It's that clock motif. Everything is all in its place. If, on the other hand, everything is contingent, where did he get that? Well, I suspect that came from Spinoza. Remember, Spinoza has the two modes. The one mode, everything is contingent, and the other mode, everything is necessary, right? Determined, and so on. So if you're a scientist doing your studies in the lab, everything that you explain has to be explained as this caused this caused this. There's no mysterious gaps that you could say, and a miracle occurred, and then you had life, right? That's not, instead you get life for free if you take the scientific approach. And that's Kaufman. Well, maybe which Kaufman? You have to be careful which Kaufman you get. Maybe I went 2 F's and 1 M. No, where is it? Stuart Kaufman. There he is. Order for free. So Stuart Kaufman, who was here, he was in Santa Fe. He worked in Santa Fe in the Complex Systems Institute, and was an invited guest here. to give us, a weekend of speeches and so on. So he was there and he was here, at separate times. So I'm not meaning to be confusing by saying he was here and there. He visited us, and I even had a fun conversation with him up in the restaurant on Alyeska, the one up at the top. And it was free, by the way. The university paid for the dinner, so that was pretty cool. Free food, right? In any case, he was a little drunk, and he was describing what life was. And he was one of the scientists that had been asked to the White House by Vice President Al Gore years ago when we were searching for life on Mars. And Al Gore asked the scientists, "What is life?" And Stewart gave the answer that life is any complex system that uses energy and reproduces itself. That's life, basically. That was his definition of life. Anything? Speaking of which, my quiz question last class was: what do you think of the idea that we are Klein bottles? Did you look up Klein bottles to see what a goofy thing that was? It's just like a Mobius strip, except 4-dimensional. Can you say that? It's a 1-dimensional thing that you can see in 4 dimensions. Does that make sense? How do you describe it? It's kind of fun. By the way, Stewart has written lots of books. Well, I should mention some of them actually real quick. Does this page have it? But he's like basing religion on science is another one of his books. But Order for Free basically means that once you get into a complex system and everything is arranged in a certain way, order comes out of it. And out of that order eventually will come life. So basically it's not a miracle where life comes from. It happens once you have the right mixture of things that becomes life. And by the way, some of at the time they were talking about the game of life. It was a computer game where you have very few little algorithms that say, when this touches this, then you have 2 of them, and so on. A little game, that you could start and then it runs and just keeps going, based on the very simple little rules of how the game works. That was part of what they were playing with, and so on. Complex systems was the theories that they were dealing with at the time. And we had a complex systems group here that was very well funded by the different earmarks that the Senate got, and our Senator Stevens got us some nice earmarks for the university. We had a lot of money at the time. Actually, it turned out to be a mistake. They didn't mean to give it to us, but they did. And so for about 4 or 5 years, we had all these wonderful orators come up from all sorts of places, like Stuart Hameroff and others. But so dealing with complex systems and complex system thinking, very, very interesting stuff. Okay, calculus wars. I mentioned that Leibniz did visit and spend 2 weeks with Spinoza, and this book, The Courier and the Heretic. The Courier was Leibniz, and the Heretic was Spinoza. So the Courier being Leibniz as he's traveling all around, learning things. One of the neat things he learned in the Netherlands while he was there was he saw how the Dutch built